Now on to our second conservation of momentum question. So this time we've got a hot air balloon is stationary at a height of 343 meters above the ground with a woman dangling from the bottom of the ladder, which is at a length of 28.8 meters long. The woman then begins to climb the ladder with a speed of 1.12 meters per second relative to the ladder. The hot air balloon by itself has a mass of 240 kilograms and the woman is 61.3 kilograms. So the first part is, what is the momentum of the woman as measured in the frame of the hot air balloon? So again, I like to begin with a diagram. So we've got the ground and a hot air balloon which is a height h above the ground, and a woman with on a ladder that is 28.8 meters from the balloon, and she is moving up, so V woman, which is 1.12 meters per second. So once again, we've got to define our coordinate system, which I'm going to choose the up direction to be my positive y direction. We don't need x because we're not moving horizontally, we're just moving vertically. And then we've also got to determine what our final significant figures will be. So every single variable that we've got here, the heights, the lengths, the velocities, and the masses, they are 3 significant figures, so our answer will also need to be in 3 sig figs. Okay, and I'm leaving that to the side. So the first question is quite simple. It's just asking, what is the momentum of the woman as measured in the frame of the hot air balloon? And we go back to our momentum equation, which is P is equal to mv. The mass of the woman we've got, and her velocity is Vw as compared as a reference of the balloon. So that becomes 61.3 kilograms multiplied by 1.12 meters per second. And our final answer is 68.7, because we want 3 significant figures, kilograms meters per second. And I should say PW. So PW is equal to 68.7 kilograms meters per second. The second part of the question is, at the top of the ladder, the woman climbs into the hot air balloon. How far above the ground is the hot air balloon? So we've got to think about this question a little bit. So basically, the woman is on the ladder and she's going up the ladder at this velocity that we defined before, and then once she gets to the top of the ladder, she gets up and climbs into the basket. So what I'm going to do is use momentum to figure out this equation. So basically, as the woman is moving up the ladder, I'm just going to write this down. Woman moves up ladder. She is transferring her momentum to the balloon until the final system becomes the woman and the balloon. So we can go back to our conservation of momentum equation. P initial is equal to P final. So our P initial is broken up into the momentum of the balloon, plus the momentum of the woman traveling up the balloon. And then our P final is the momentum of the balloon plus the woman. Just gonna scroll down. So we know that the balloon is initially not moving, so we can say that it has no momentum. And the momentum of the woman we have defined above, so that's PW. Our final momentum is as I said, momentum of the balloon and the woman. So let me just rewrite this, which is M woman plus V woman. So our final momentum is the mass of the balloon plus mass of the woman, multiplied by the final velocity of the system, which I'll call Fs, just so you know that it's the system velocity. So now we can start plugging in the numbers. So we have MWVW, the momentum of the woman, written above. So again, keep the significant figures in your calculator. So that's 68.7, which is equal to the mass of the balloon, which was 240 kilos, plus the mass of the woman, which was 61.3, and we calculate for our final system velocity. So if we crunch the numbers, we get VFS is equal to 0.228 meters per second to 3 significant figures. We can also just look at this velocity now. Intuitively, we know that as the woman is going up the balloon, the velocity is going to go down. So because we defined the up direction to be our positive y direction coordinate, then we can say that this is a negative velocity as the woman is transferring her momentum to the balloon. So this VFS will be negative 0.228 meters per second. Now back to the original question, it's asking us to calculate how far above the ground the hot air balloon is after the woman has traveled up the balloon. So the easiest way to do this is to just look at how long it takes for the woman to travel from the bottom of the ladder to the top of the ladder. So we know that the ladder is 28.8 ladder length, 28.8 meters. And the woman, V woman, is equal to, what did we say it was? 1.12 meters per second. So then time, so that's what we're trying to calculate, is how long it takes her to move up the ladder. Which is equal to the length that she has to travel, which is 28.8 meters, and we divide that by the velocity of 1.12 meters per second, and we get a final answer of 25.7 seconds. Now we can use this time to calculate how much the balloon moves down, because we have a velocity of the system as the woman transferred her momentum onto the balloon, and then from there we can calculate how much the displacement of the system is. So displacement, which I will refer to as S of system, I'll just call that SS, is equal to velocity multiplied by time. So our velocity was, let's just keep the sign, negative 0.228 meters per second, and we multiply that by how long it took the momentum transfer to occur, and that was 25.7 seconds. So our total answer is negative 5.86 meters to 3 significant figures, and our direction is down. So basically, what this is saying is that as the woman was traveling up the ladder, the ladder moved down 5.86 meters. So the question is asking, what's our final height, which is equal to the initial height we were at, which was 343 meters, 343 meters, minus the 5.86 that the momentum transfer caused, and we get a total answer of 337 meters. So that's our final answer. And that's to 3 sig figs. And this is again above ground, so don't forget that. So that was our final question for our conservation of momentum section. I hope you guys liked the question. Please don't forget to like, subscribe, and view our channel. Thanks, guys.